The name Kyle has been synonymous with quality overhead distribution switchgear products for over 50 years. Now, with the increasing need for underground distribution protection, Kyle is leading the way with the Type VFI vacuum fault interrupter. The Kyle Type VFI vacuum fault interrupter represents the latest technology in pad-mounted switchgear. Overcurrent protection is accomplished with Kyle vacuum interrupters instead of fuses. The self-powered electronic control provides an extensive choice of minimum trip settings, time current curves, and operating features. The VFI's resettable breaker mechanism allows immediate service restoration, eliminating the added downtime and expense associated with changing out conventional fuses. In this program, we'll cover the description of the VFI's features and operating components, manual operation of the unit, a description of the features and theory of operation of the tri-phase electronic control, control programming instructions for changing control settings, testing procedures using the electronic trip control tester, and routine maintenance and inspection procedures. Switchgear must be properly selected for the intended application. It must be installed, operated, and serviced by competent personnel who have been trained and understand proper safety procedures. The VFI is not intended to protect human life. We urge you to always follow all locally approved procedures and safety practices when operating and testing this equipment. VFI vacuum switchgear provides fault interruption and convenient load switching for 15, 25, and 35 kV underground systems. It's available in single-phase and three-phase configurations and is designed for industrial, commercial, and residential applications. VFI switchgear meets ANSI pad-mounted standards for dead front construction and enclosure security. Dead front construction minimizes the high voltage safety hazards for both the operator and the general public. The VFI has a padlockable cabinet, which should be locked at all times to prevent contact with hazardous voltage. Power is fed underground to and from the switchgear through openings in a concrete pad. The VFI has recessed lifting provisions, parking stands, and operation one-line diagrams. In this configuration, the source side has an oil fill plug, oil level indicator, load brake switch, and dead front bushings. The tap side includes the tri-phase control, three-phase gang trip VFI, single-phase trip VFI, and bushing wells. Standard top hinge doors or optional side hinge doors are also available. The nameplate specifies the voltage and current ratings of the unit. VFI uses either oil or SF6 as the insulation medium. Load and fault interruption takes place within sealed vacuum interrupters, eliminating the threat of contamination to the insulating medium. The VFI has fault current interruption and load make and load break switching capabilities. The fault interrupter mechanisms can be configured for either single-phase or ganged three-phase operation. Current sensing transformers, or CTs, provide line current information to the control. When the line current exceeds the minimum trip setting, the control initiates a signal, which causes the VFI to interrupt the circuit. The VFI mechanism is equipped with hot stick operable handles that are typically mounted on the tap side of the unit. The operating handles provide push to close, pull to open, and pull to reset operation. They can be padlocked in the open position. Single-phase operation trips each phase independently. Three-phase operation trips all three phases simultaneously. When operating and testing this equipment, follow all locally approved procedures and safety practices. The VFI can be manually operated for load break, load make switching using the operating handles. The VFI push-pull operating handles must be operated with a hot stick. Manually open the VFI by pulling the operating handle to the open position. To reset the mechanism, pull the operating handle until the latch resets. After the latch is reset, the VFI mechanism can then be closed by pushing the handle to the closed position. The Keil tri-phase control provides the operating intelligence for the VFI. The tri-phase control can be mounted on a side hinge door or the tank of the VFI unit, depending on the application. The tri-phase electronic control is a solid-state circuit board with a plug-in time current curve or TCC module. Dip switches on the control circuit board set the minimum trip levels for each phase, activate and program instantaneous trip, and also allow selection of single-phase or three-phase trip. The control settings decal, located on the inside of the control housing cover, provides a reference for setting the control's minimum and instantaneous trip values. The tri-phase control has a switch, allowing for either single-phase independent or gang three-phase tripping. For units with 3 single-phase trip handles, the control can be set for independent operation of each phase. When set for ganged operation, a fault detected on any phase causes the simultaneous interruption of all 3 phases. The control requires no external voltage supply or battery backup because it's powered by system current through the CTs. It's not affected by system voltage conditions such as overvoltage transients. At normal system current levels, load current is continuously being compared to the programmed minimum trip values. The TCC circuit is activated whenever current exceeds the pre-selected minimum trip value. When it's activated, the TCC circuit uses the magnitude of the overcurrent to establish a time delay. At the completion of the time delay, the trip circuit generates a pulse which actuates the flux shift tripper, releasing the switchgear operating mechanism to open the main contacts. An assortment of field-replaceable TCC modules is available. Each provides a fixed time current curve characteristic. The TCC module is a resistor-capacitor network, which sets the response time characteristics of the control for line currents above minimum trip. The trip circuit compares the output voltage from the time delay circuit to a fixed reference voltage. When the output voltage equals the reference voltage, the control issues a trip signal to open the switchgear. Changes to the control settings should only be made by a qualified technician or engineer. Minimum trip levels for each phase are programmed independently and are determined by the position of dip switches on the control circuit board. Each dip switch bank has 7 switches, each representing an incremental minimum trip value. Operating a switch to the on position increases the minimum trip level, while moving to the off position decreases the level. Minimum trip levels can be programmed from a minimum of 20 amps to a maximum of 1290 amps in 10 amp increments. On a de-energized unit, for example, let's say the desired minimum trip value for phase A is 340 amps. Refer to the control settings decal. 340 amps minus the 20 amp default minimum trip setting leaves 320 amps to be programmed. Make sure that all the switches on the bank are turned off. Identify the switch numbered 320 and turn it on. If the VFI is energized, move all the switches to the on position before changing the minimum trip level. This will prevent an inadvertent trip operation. Instantaneous trip bypasses the normal time delay characteristics to provide instantaneous tripping in response to high magnitude faults. With instantaneous trip, fault duration is reduced and coordination with source side protection is extended to provide improved system coordination and selective zoning. A separate dip switch bank on the control activates and programs the instantaneous trip feature. A multiplier is applied to each phase minimum trip setting to set instantaneous trip current values. When the fault current exceeds that value, the control will trip immediately, eliminating any intentional time delay. For faults below the instantaneous trip level, the control operates according to normal TCC characteristics. The instantaneous trip multiplier may be programmed from 1 to a maximum of 15 times in odd number increments. Each phase may be set at a different minimum trip setting, but the instantaneous trip multiplier is common for all phases. Refer to the control settings decal. Before setting instantaneous trip on an energized unit, set the off-on switch to off. The off-on switch activates instantaneous trip and provides a 1 times multiplier. For example, to set the instantaneous trip at 7 times minimum trip, set the 2 times and 4 times switches to on. Lastly, set the off-on switch to on for a total of 7 times minimum trip. The instantaneous trip feature is disabled by moving the off-on switch to off. Time delay curves are set by the TCC module. The control must have the module installed for proper operation. If it's missing while the switchgear is energized and a fault or overload occurs, the switchgear will trip in approximately 20 milliseconds. To replace the module, de-energize the switchgear if possible. Push down on the retainer clip and pull it free from the receptacle. Install the replacement module into the receptacle and snap it onto the support post. The minimum response time accessory achieves coordination between inline protective interrupting devices where fault currents could cause simultaneous tripping. The accessory inhibits tripping until a predetermined minimum time has elapsed. Let's say, for example, that the minimum response time selected is 0.145 seconds. When current above the minimum trip level is detected, the accessory activates, modifying the TCC minimum response time to 0.145 seconds. The minimum response time accessory is a special version of the TCC module. It provides both time current curve and the minimum response features for the control. It is activated by moving the slide switch to the desired response time setting. Moving the switch to the standard position disables the accessory and provides normal response timing. Periodic tests of minimum trip and time delay can be conducted to verify proper operation of the tri-phase control. The control can be field tested in its housing or tested in a suitably equipped service facility. We'll test the control with the Kyle ETC electronic trip control tester. De-energize the switchgear according to locally approved procedures before removing the circuit board. Then move the VFI's operating handles to the open position. Disconnect the VFI control cable from the pin connector labeled P1 on the circuit board. Next, remove the 4 circuit board mounting screws. Now, carefully remove the circuit board. To prepare the tester, make sure the main power switch is off and the control power switch is on. Also make sure that the trip switches in the 2 interrupter panel section are in the off and block position. Adjust the current to 0, the ammeter range to 200 amps, the phase selector to A, the fault time select switch to response, and the fault switch to the fault position. To connect the circuit board to the tester, attach the adapter cable accessory between the connector labeled to control and pin connector P1 on the control circuit board. On the adapter cable accessory, set both the input and output phase selector switches to the A position. Set the external Zener switch to the out position. Now, connect the power cable and turn the main power switch on. After the power is on, be sure that the interrupter simulator is in the open position. The minimum trip test verifies that current sensing, minimum trip, instantaneous trip, and trip circuits are all operational. Control tripping with an applied test current that is within plus or minus 20% of the actual minimum trip setting indicates proper operation. To perform the minimum trip test, set the control's instantaneous trip switch to 1 times minimum trip and set the minimum trip for each phase to 50 amps. Keep in mind that the default minimum trip setting is 20 amps, so only the 10 amp and 20 amp switches are moved to the on position. Before you begin testing, press the clock reset button. Then press the close button in the panel labeled Interrupter Simulator. Now, to simulate the load, push in the Simulator Trip Coil button to set for tripping. Slowly turn the current adjust knob until the interrupter simulator trips. The green open light will come on. Note and record the current reading on the ETC ammeter display just prior to tripping. Repeat the procedure to test phases B and C. Set the ETC phase selector switch and adapter cable input and output phase selector switches to the phase B or C position. If the measured minimum trip current falls outside the plus or minus 20% range, or if the control fails to trip the interrupter simulator, the control circuit board must be replaced. The time delay trip test verifies that the time delay circuit is functioning. The ETC tester is first calibrated to deliver a fixed value of fault current to the control. The control should then respond with a trip signal. The time delay between the application of current and the receipt of the trip signal is recorded on the ETC time display. To test time delay trip, follow the same tester setup procedures as in the minimum trip test, except the adapter cable Zener switch must be moved to the in position. Now turn the main power switch on. To perform the time delay trip test, set the minimum trip for each phase to 50 amps. Then set the interrupter simulator to the closed position. Next, hold the fault switch in the calibrate position while setting the desired test current level to 2 times minimum trip for a total of 100 amps. Reset the clock and move the fault switch to the fault position. The time delay reading must be within plus or minus 20% of the published time current curve. To verify proper time delay function, repeat this procedure using at least 3 multiples of minimum trip on each phase. High potential withstand tests are performed to verify the vacuum integrity of the interrupters used in VFI switchgear. For the recommended high potential withstand test voltages, refer to the VFI service manual. To prevent accidental contact with high voltage parts, the switchgear must be placed in a suitable test cage and all proper grounding and safety procedures must be followed. With the vacuum interrupters open, perform an AC high pot test for 1 minute or a DC high pot test for 15 minutes. A routine maintenance inspection program is required to ensure proper operation of the Kyle vacuum fault interrupter. The insulating oil must have a minimum dielectric strength of 26 kV and should be tested within 2 years after the installation of the unit. These test results will establish a benchmark reference for observing trends in the unit's normal operation and to diagnose any fault conditions that may be present. After the initial oil testing and inspection, the VFI should be maintained at least every 6 years. However, we recommend regular external inspection of the VFI. First, de-energize, ground, and remove the switchgear from service. Then reduce the internal tank pressure and check the oil level. Next, inspect the unit for unusual wear to the paint finish and damage to the bushings and elbows. Make sure all connections are secure. Check for oil leaks and any other abnormal indications of wear or abuse. Record and date the inspection findings on the permanent maintenance record of the unit. For detailed maintenance, inspection, and oil testing information, refer to the VFI service manual. Lastly, make sure that the cabinet doors lock securely. Let's review what we've covered. In this program, we've described the features and operating components of the VFI, manual operation of the unit, a description of the features and theory of operation of the tri-phase electronic control, control programming instructions for changing control settings, testing procedures using the electronic trip control tester, and routine maintenance and inspection procedures. For detailed information regarding the Kyle-type VFI vacuum fault interrupter, contact your Cooper Power Systems sales representative.